Laplace transformation. The concept which are going to Laplace transform. Laplace transform simply implies Laplace function of t is equal to integral from 0 to infinity of f of t dot exponent minus st dt. Laplace transform is very much key in engineering application and science application, and also in advanced mathematics and advanced physics. However, if we are given a challenge, find Laplace of A, we go to the general expression for Laplace transformation, which is Laplace is a function of time is equal to integral O to infinity. A will now replace f of t, which gives us a dot exponent minus st differential t. Note that this is a range from point of origin to an unknown end, an infinitesimal function. So, but however, since a is a constant, you get it out of the integral sign to be O to infinity of exponent minus st dt. As a definite integral, we will now integrate the function to get a dot reciprocal of s exponential minus st from point of origin to infinity. At this level, we substitute the value of the definite integrals to get the final answer, and that gives us a into reciprocal of x with a negative sign of exponent infinity minus exponent 0. So at this level, of course, the brackets are 2 in nature. So this gives us minus a divided by s brackets 0 minus 1. Any function to exponent infinity tends to 0. Function to exponent 0 tends to 1. So when we open the bracket, we will have a over s. So example of this is find Laplace transform of minus 4, which is a constant. Laplace transform of minus 4, as it is, gives us integral minus 4 O to infinity of exponent minus st dt as a constant. This gives us minus 4 integral O to infinity of exponent minus st dt. And this is minus 4 into, as it is, it gives us into 1 over s, if you care to, or you undergo same process of the expression below, which is the same thing as minus 4 over s directly of 0 minus 1, which has been treated as a constant, and this gives you 4 over s. But if you take note of the implication, the negative sign implication, we now see that the negative sign here, which was erupted based on this relationship, has a direct effect on the expression, so that the implication of the negative sign as a reflection must come up as minus 4 over x. If ambiguity is certain, then of course you can undergo another relationship, because negative sign effect minus 4 Laplace of it ordinarily unknown. If you don't understand the process clearly, we can now make it as event to give us Laplace A is equal to A over S. So Laplace of minus 4 is equal to minus 4 over S. So minus 4, of course, with this relationship having a constant where this connotation is related to A integral exponent minus st dt from point of origin to infinity, Laplace transformation model, assuming A is also a function of -4. You see the connotation and the reflection, because when this was worked, we have A into -1/s into 0 minus 1. So if this connotation is taken into cognizance, and we are having -4 here, it means by implication that a reversal of the multiplicity value of -1 will now exist, which is -1, to multiply the whole of this function. And when that happens, you get this. So, but of course, you could do it directly by just imputing in the formula relationship, which is Laplace A, which is A over S. And A over S is also depicted as -4 for A. So impute -4 for A and you get -4 over S. That's all. In another relevant concept, if we are to find Laplace transform of exponential AT, for example, this also flows in as Laplace of exponent AT is equal to integral O to infinity. The function of time that is here will now be replaced with exponential AT dot exponential minus ST dt. Take note, in Laplace transformation, S is the Laplace transform. Actually, the application of Laplace came into being when differential equation, ordinary differential equation resolution was compounded, and the applications of mathematical programming such as MATLAB and Python programming, the inputs of the variables with respect to normal differential equation by Isaac-Newton is difficult, but Laplace was an alternative methodology of solving cloud mathematics. So with time, we'll look at the mathematical programming and how to depict the scripts of Laplace programming. So when we arrive at this point, however, multiplication sign, of course, gives you addition, and that gives us integral function of point 0 to infinity of exponent minus st plus at differential t. If this is invoked because of the multiplicative order of the exponential function, so we now have integral O to infinity of what? Of exponent minus into s minus a bracket t differential t. Of course, you can see that at this point we'll be able to factorize the negative sign out of the function to integrate as O to infinity of this function. If we go direct into the integral of exponent minus of s minus a t differential t, which gives us reciprocal minus reciprocal s minus a, that is the entire function. Now we'll be having a repetition of minus into s minus a t from 0 to infinity as a definite integral function. So this gives us again minus 1 over s minus a. As you can see, we are just applying integral principle. You reciprocate the exponential function of what is with t here. Now, if that is reciprocated, you have 1 over s minus a. Exponential minus into s minus a. You close this when we are substituting. With respect to infinity, the upper limit minus exponential minus s minus a, 0, the lower limit. You close. When this is closed, we now have minus 1 over s minus a into exponential infinity gives 0 anytime you resolve it, while exponent 0 also gives 1 once it is resolved. Opening the bracket, this gives us a reciprocal of s minus a. So universally The Laplace transform of entity exponential minus a is actually a different thing from this. Remember, if we are now giving Laplace of exponential minus at, like I was saying,